In this clip, we will see what is the meaning of direction cosines of a vector, okay, or direction cosines of a line or a vector, both mean the same. Direction cosines, we will see. Now, let us consider the same thing like how we considered in the previous case. Let us consider a point P in free space, that is nothing but in a three-dimensional plane. Let us consider x, y, z. Let us consider this is the origin O of the coordinate space. So, let us consider one point P and I will connect the origin to the point P and I will get one position vector. That position vector I will indicate as vector R. Now, as you can clearly see that this particular line is inclined to the x-axis by an angle alpha, is it right, by an angle alpha. Similarly, this line makes an inclination of beta with the y-axis and this line makes an inclination of gamma. This actually I cannot show that gamma, that z-axis is either coming towards you or it is going inside the plane of the board. So, basically that gamma is this angle, okay, the angle between the z-axis and the line, that is gamma. Here I will for representation I will show like this. Now, what is this alpha comma beta comma gamma? Alpha comma beta comma gamma are called as the direction angles. They are called as direction angles. Is it okay? Direction angles. Now, what we will do, we will drop one perpendicular like this. I will just show you for x-axis. Then, if you want to calculate for y-axis, you may rotate this. Okay, permutation you can do. X-axis you take it here, y-axis you take it here, z will come here. Then you can calculate the z component. So, I may write similarly here, correct or not? So, if I drop this like this, so what is this part now? This part will correspond to x, right? Because from the origin I have to travel x distance in order to reach the x component of this particular point. All right. So, and what is this? Now, if I consider direction angles, no, the cosine component, the cosine component of the direction angles, the cosine component of the direction angles are called the direction cosines of the direction angles are, the cosine component of the direction angles are called the direction cosines, is it okay? Direction cosines. So, what you have to do? You have to take the cos component of this, that is cos alpha, if you can consider in this particular triangle OPQ, if you consider this triangle in triangle OPQ, I can say this is nothing but OQ divided by what is it? OP. So, this is nothing but x divided by not vector r now, it is just the magnitude because OP is the length, yes, x by r. Similarly, if I want to calculate cos beta, what do I get? I will get cos beta is equal to y divided by r and I will get cos gamma, that is equal to z divided by r. So, we discussed, right, what is magnitude of r? Magnitude of r, which is simply r, that is equal to root over what is it? X square plus y square plus z square, right? X square plus y square plus z square. Now, I will call this as equation number 1, I will call this as equation 2, I will call this as equation 3. All these we have made use of in problems. Is it okay? Now, what I will do is, first you study this theory correctly and try and understand. We'll square and add the three equations. We'll square and add. Is it okay? 1 square plus 2 square plus 3 square. When we square and add, what do you get? Cos squared alpha plus cos squared beta plus cos squared gamma. Is it okay? Cos squared gamma, which will be equal to. So, now this cos alpha, cos beta, cos gamma, before I proceed, I will tell you. Cos alpha is algebraically denoted by the letter M. Cos beta can also be denoted by the letter L. This is L, cos alpha is L, cos beta is M and cos gamma is N. Okay. These are the notations. These are the notations for direction cosines. Notations, these are L, M, N. Is it okay? You should know this. Cos alpha is L, cos beta is M, cos gamma is N. This is the notation followed. So, I may say this is nothing but x square divided by r square plus y square divided by r square plus z square divided by r square, right. So, I may write this like this, L square plus m square plus n square, that is equal to, because cos alpha is L, cos beta is M, cos gamma is N. So, I may write this as x square plus y square plus z square, x square plus y square plus z square whole divided by r square. So, I may say L square plus m square plus n square, that is equal to, look here, what is r square? R square can be written as now what? Squaring on both sides, x square plus y square plus z square, square on both sides. Is it okay? Squaring on both sides. R square is nothing but x square plus y square plus z square. So, I can write this as r square divided by r square. So, I can get one important standard result here. sum of squares of direction cosines of a line is always what is it? Unity. Unity is 1. So, this is one very important standard result where problems in the competitive exam have been asked from this part. Okay. So, I can say L square plus M square plus N square, this is equal to 1. That is, I can also write like this, cos squared alpha plus cos squared beta plus cos squared gamma, that is equal to what is it? Cos squared gamma, that is equal to 1. This will be the required answer to the given question. Are you following? So, this is about direction cosines of a line.